Support for the Idaho Matters podcast is brought to you in part by University of Idaho, Idaho's only Carnegie R1 classified research university. Our Carnegie R1 designation recognizes the discoveries we make that help our forests thrive. It means we're creating more doctors and doing real research to strengthen cybersecurity for Idaho businesses, our energy sector, and every Idahoan. More at go.uidaho.edu/Idaho-is-Idaho.
Boise State Public Radio and Duck Club Entertainment present the Charlie Hunter Trio.
Charlie Hunter Trio, everybody.
Wednesday, March 18th at the Shrine Social Club in Boise. Blending jazz, funk, blues, and rock, Hunter is a guitarist, producer, and bandleader who will present his unique finger-picking technique on custom hybrid guitars. Tickets are available now at theduckclub.com.
You're listening to Idaho Matters from the studios of Boise State Public Radio News. I'm Gemma Cadet. So have you ever wondered how planets are formed? Well, if you have, you're not alone. Dr. Charles Law is a NASA Hubble Fellowship Program Sagan Fellow, and he spends his time studying just that, using radio telescopes to understand how planets take shape and what makes them unique. And he's joining us now to talk more about this. Welcome to the program.
Hello, thank you for having me. Excited to be here.
Can you start out by explaining in simple terms, for those of us who aren't scientists, how planets are actually formed?
Yes, absolutely. So planets are formed essentially by stuff sticking together. They form out of a primordial soup of gas and dust that is out there in these giant clouds of stuff out there in interstellar space. This material ends up collapsing down, and through a long, complicated process, you end up having materials stick together and grow progressively larger and larger and larger until eventually you have something that resembles a planet.
Huh. So you use the ALMA telescope to study planet formation. For folks who may not be familiar with this, what makes ALMA so special if you compare it to other telescopes?
Yes, ALMA is fantastic. ALMA is a acronym for the Atacama Large Millimeter Array because it is located in the Atacama Desert of northern Chile. The things that make it particularly special is its size. It is actually not just one telescope, but 66 individual radio antenna, that all cooperate and work together to be essentially a super telescope. And that allows us to have very, very high resolution and very high sensitivity to see even the faintest of objects. And I use it in particular to understand how the planets form by looking at the raw materials that go into that. We can actually detect the dust and the gas that goes into making our planets by using the ALMA telescope.
So my understanding is that there are more than 6,000 exoplanets that have been discovered so far. So what have these distant worlds taught us about how planetary systems can differ from our own?
Yes, that is right. It's now over 6,000 confirmed other worlds, and that number just keeps ticking up every day. So I really expect that number to keep increasing. But what we've actually learned from looking at these populations of other worlds is that the process of actually making a planet is actually very diverse. Our solar system is just one way to make a planetary system. And when we look at these other worlds, they have vastly different properties. You have planets that are much larger, that are much smaller, that are located at entirely different regions with respect to their host stars. So what it's telling us that, yes, the solar system we live in is one possible planetary system, but there are many, many others out there.
Okay, so you study astrochemistry. Have you found evidence that the building blocks of life actually exist beyond our solar system?
Okay, that is a great question. I'll just back up and at least explain what astrochemistry is. It's a fancy term for essentially looking at chemistry out there in interstellar space, basically using molecules, and we actually happen to find them out there throughout all of interstellar space, using those molecules to learn something about astrophysics and physics more broadly. And so to get to your question, we do look at these forming worlds. We look at the material that's actually going into young planets, and we can figure out what that gas composition is, what molecules are there, how much of them are there. And so I hesitate to necessarily say, yes, we've absolutely found exactly the molecule that's exactly going to make life. But instead, what I can say is that we do have mounting evidence that planets do form in very dense environments with lots of molecular gas. And whenever we look, we're always surprised. We find more and more complex material, more molecules that potentially can get us there to prebiotically relevant molecules that will eventually lead these planets, at least in a subset of these systems, it seems like, to be able to form life at some point. Now, exactly what type of life and when, those are entirely open questions, but the evidence is going in that direction.
So, by studying things like exoplanet systems, does it help us understand more about our solar system and maybe even like the history of our solar system?
Yes, that's absolutely right. We get a window into how our own solar system formed, and we can find those that are perhaps analogs, those that look quite similar to our own solar system, and basically look back in time. We can't watch what's happening in our own solar system. We go back billions of years, but we can look at these other systems that tell us that story about how we came to be.
What has been the most surprising discovery that you've made or observed in doing all of this research?
One of the most surprising things that really excited me is that we've actually found in some of these systems that we can use this tool of astrochemistry, not just to learn about the composition of the material around the planets, but we can actually see as a planet is forming, it changing its local environment. So we can actually use chemistry to tell us, oh, we see actually, oh, there's a planet sitting right there in this one protoplanetary disk. That's the technical jargon for these environments where I study. But we can actually use chemistry to find the very youngest of planets, not just characterize where they're forming, but actually find them directly.
So if we have a student listening and they want to one day study planets or become an astronomer, what's the one piece of advice you would give them?
Oh, to boil it down to one piece of advice is quite hard. I guess I would say to stay curious, to be interested about how things work in the natural world, and then to act on that. And I guess in terms of sort of concrete advice, it's always great to have more background and info in physics and in astrophysics, and to learn how to program. All of these skills sort of underpin the daily activities that you do as a research astronomer. But all of it, I think, really is driven by that natural curiosity about the world around you.
And before I let you go, can you remind us when and where your first Friday astronomy talk is going to be taking place?
Yes, it's going to happen at 7:30 in the education building on Boise State's campus. And in particular, it's in room 112.
Well, I want to thank you so much for taking time to talk with us. Really appreciate it. We've been speaking with Dr. Charles Law. He is a NASA Hubble Fellowship Program Sagan Fellow. We've been talking about how planets are formed, and he'll be talking more about this tomorrow at 7:30 p.m. in the Education Building at Boise State University, and it is open to the public. You've been listening to the Idaho Matters podcast from Boise State Public Radio. To stay in touch, you can find quick Idaho Daily News every morning when you subscribe to the Connector podcast. If you learned something from this episode today, share it with someone else who needs to know about it.